The shape of the distribution of the time required to get an oil change in a 10-minute oil change facility is unknown. However, records indicate that the mean time is 11.1 minutes, with a standard deviation of 4.1 minutes. So to start with, to compute probabilities regarding the sample mean using the normal model, what sample size would be required? About the original data, we're told we don't know the shape of the distribution. We don't know if it's normal or not. So we need a sample size that is 30 or greater than 30. So I'm going to choose C. So all this is stating is that to use the following procedure, you can't have a small sample size. If you start at 30 and you have something that's greater, then the new distribution will be approximately normal. So in part B, it says what is the probability that a random sample of 40 oil changes results in a sample mean time less than 10 minutes? We can now use a normal distribution to answer this problem. I'll open StatCrunch and open the normal calculator. So go Stats, Calculator, and choose Normal, this thing. In part B, it says that we want the probability that the sample mean time is less than 10 minutes. So if you're looking for a probability, that's going to be the red area on this distribution. And it's already set up to be less than, but I want to change this to 10. Also, we're going to need a mean and a standard deviation. Well, we're given this mean here, and this will be the same as the mean of the sampling distribution. So I'll put in 11.1 minutes. And I see there's the standard deviation, which is 4.1. This is not the standard deviation that we're going to use, but just to see the number that we get. Okay, it looks like the answer would be like 39% approximately, but this would be for a sample size of 1. The probability that one person has an oil change that's less than 10 minutes would be about 39%. And this is saying, well, what if you had 40? And what we're going to do is adjust the standard deviation. So we're not going to use the standard deviation from the original sample. And the reason is because we're talking about a sample size greater than 1. The formula is to take this standard deviation and divide by the square root of the sample size. So I'll state it as it's 4.1 divided by the square root of 40. So I'm going to use a calculator to figure out that value. So on this one here, I would start with the original standard deviation, 4.1, and I'll click divide by. And then in the denominator, I want to enter in the square root of 40. It's a little weird to do this on this calculator, but you have to open a parenthesis. You first have to type in the number 40 and then take the square root. And this is the square root of 40. And by opening this parenthesis, it's going to put it into the denominator when I clicked divide by. So I'll close the parenthesis saying I'm done with the denominator, and I'm dividing this number into 4.1. And here we get 0.6482, and I'll round this 6 to a 7. That'll be pretty accurate if I go out to, let's say, like 5 decimal places. So that's 0.64827. That should be good enough. Okay, with this new information, what we have is a standard deviation that is going to correspond to a sample size of 40. So if I click compute, I get this value here. And this seems more reasonable. If I round it to 4 decimal places, this 8 gets rounded up to a 9. And therefore, my answer is going to be 0.0449. So the only big change there was we're still using a standard deviation on a normal calculator, but we have to adjust it from the original one. All right, so there is a last part to this problem. Quite a wordy statement here in part C, but essentially what this part is asking us to do is to go backwards in this calculator. So like before, we entered in a time and we got a probability. This time, we are given a probability of 10%. Well, really, that would be 0.10. And we want it to correspond to a mean time in minutes. So I perceive this problem as, instead of putting in the time to get the probability, I'm going to enter in the probability of 0.1, which is 10%, to get this time here of 10 well, if I round, it'll be 10.3 minutes. So I'll put in 10.3. I'll check my answer. So that is everything for this problem. We're still using normal calculator, but the second that you talk about a sample size that's bigger than 1, you can't use this original number. You have to adjust it, and that's everything for this problem.